completed this yesterday. Now we will continue. I'll tell you some things that we can know just by looking at this formula. First, is that this potential due to a dipole, short dipole, is proportional to 1 by r square, not to 1 by r. For a point charge, V is proportional to 1 by r. Yes or no? Yes. And this is for a dipole. Is that clear? So that's one big difference between them. Is it fine? Okay. Second thing to know is about direction. You see, the potential due to a point charge is kq by r. It does not depend on direction. That is only depends on the distance from the charge q. Doesn't matter. Clear or not clear? Clear. Sure.
Yes.
But over here, there is theta. That is, it depends on the direction. That is the angle between p vector and r vector. Okay. So just write it here. Depends on direction, and for point charge does not depend on direction. So I hope you understood how they are different. Clear? Right? This one depends on direction. For dipole, electric potential depends on direction, but for point charge it does not depend. Is it fine? Do you understand?
Yes.
Okay. Shall I erase it now? Let's go to the next one. Electric potential energy of a dipole placed in uniform external field, electric field, uniform external electric field. ગામે દેખશું તમને લોકોને નહીં ને વાંધો નહીં. Do you remember in the first chapter we have learned that if you put a dipole in a uniform electric field, then there is a torque acting on it. Yes or no?
Yes.
How much torque? V sin theta. Okay. So this is actually continuation of that topic. The only difference is there we talked about force and torque. Here we will talk about potential energy. The link check. Okay. The division is artificial. Okay. Fine. Let's start. So suppose that there is some electric field, right? Okay. And in this electric field, a dipole has been fixed. Let's say some angle is. So that angle between dipole moment and electric field is theta. Fine so far? Clear or not clear? Okay, so we are saying that suppose that a dipole has been placed. See, when you write all these derivations, you should note down or you should start with these sentences. Okay, consider a dipole placed in uniform electric field as shown in figure. Okay, the angle between dipole moment and electric field is theta. Is it fine? Much better then. So that's why you should always start by drawing a diagram, because the moment you draw a diagram, everything is in front of you. Then you can write sentences easily without memorizing anything. Okay, self-description, just describe what you are seeing. Okay, just describe what you are seeing. That's it. Okay. Now, let's say this charge is plus q, this charge is minus q, and as usual, distance between them will be 2. Fine. Now, if I want to find out the potential energy of this system, right, we will first of all consider that if we want to rotate it slowly, right? So, to rotate the dipole slowly, that is without increasing what? Without increasing what? Kinetic energy. Is that okay?
Yes.
Right? To rotate the dipole slowly without increasing kinetic energy from angle theta 1 to theta 2. From angle theta 1 to theta 2. So suppose some angle is theta and then you want to turn it. Right? So from initial angle to final angle. Is that okay or not okay? Pretty nice. The external work done should be equal to minus WE, that should be equal to delta. Okay? Okay or not okay? So, if you want to rotate the dipole slowly, see, first of all, in this given position, the electric field will try to rotate it. Listen to what I am saying. In the drawn position in the diagram of there, electric field will try to rotate it in which manner? Clockwise or anti-clockwise? Clockwise. Is that clear?
Yes.
And we want to rotate it slowly, so definitely we can only rotate it in the opposite direction. Yes or no?
Yes.
Yes or no? તમે આમ બોટ લગાડશો તો slowly rotate નહીં થાય તો આમ ભાગશે. Clear or not?
Yes.
Okay, so we are going to rotate it anti-clockwise. Clear? We are going to rotate it anti-clockwise. So, does that make sense?
Yes.
So this is equal to what? PE sin theta. PE sin theta. D theta. I other? Yes, no? Let me go through this here. Let me go through this. Do you remember in rotation, the formula of work done by force would not be F dr cos theta, it would be torque d theta. Yes or no? It will be torque, right? Work done not by the force but by the torque. Everyone remember that?
Yes.
Okay, so that's why when I write work, I should be putting torque d theta. Clear or not? Everyone. And we are taking anti-clockwise as positive. So, આપણે આને આમ જ રોટેટ કરવાનું from theta 1 to theta 2. Clear? And that will be equal to delta U. Understood? Understood or not?
Yes.
This is this one. Okay? Fine. Now, dot formula PE sin theta. B theta, theta 1 to theta 2 is equal to U2 minus U1. Yes or no? You know, right? Final minus initial. So, this would give over here P constant outside. Integration of sin theta is cos theta minus cos theta. Then now square bracket limits theta 1 to theta 2 is equal to U2 minus U1. Everything makes sense so far?
Yes.
Our work in the formula. Okay? Everyone there? Good. But minus E. Now here, what to do? Cos theta 2 minus cos theta 1. So, what's this careful? First of all, if I put cos theta 2, I get this term. Why I have multiplied P. Then I have to put the minus sign for the difference between these. Yes or no?
Yes.
Upper limit, then you put a minus sign. Now you write lower limit. Is this clear? Clear or not?
Yes.
Go with the minus sign, they confuse us. And we will not change it to positive. We will not change it to positive. So, multiple maths. Okay, if you don't do it directly, no problem. You can come here after 2 or 3 steps. Right? Right? Okay, so we write it like this. Now, the reason to write it in such a weird manner, I'm being clear. I don't want to write it like that because right side is U2 minus U1. So, I want to express everything ultimately in that form. Something minus something. Okay?
Yes.
What's a plus? Got it or not?
Yes.
Okay? So this is U2 and this will be U1. Fine? You know, it happens like this always, if you remember. Okay? It happens like this always. Whenever we try to find potential energy, we can always find delta U, we can never find U. Yeah, so 11. Okay? In U, for MGH and all that, we derived that U will not be MGH, it could be MGH plus some constant. એવું જ આમાંય થાય લખવું. So we'll take appropriate reference. Okay? So taking theta equal to theta 1 equal to 90 degree for reference. Okay, so U1 will be equal to 0. Is that okay or not okay? I am taking the initial as reference. And for reference, potential energy is always 0. Sure? Everyone get that?
Yes.
So theta 1 equal to 90 degree in a reference like that point. That is when the dipole is like this. Okay, and field lines are like this. Did you get it?
Yes.
We are taking this situation as the reference. You got to that theta 1 90 and U1 will be 0 for reference. Okay, so now if you put it here, okay, minus PE cos theta 2, what is your minus 0? Yes or no? You're not clear. Kept 0. Cos 90 0. Fine is equal to U2 minus 0. Got it? Got it or not?
Yes.
Kept U1 0, we took it as reference. Okay, that would give U2 equal to minus PE cos theta 2, or in general, U is equal to minus PE cos. We write it in one more form. P vector dot P vector. Alright? You know, this is a good choice of reference. Why is it a good choice? Right? It is actually natural that this point has 0 potential energy. Right? In this situation, the dipole has 0 potential energy is actually natural. We can derive it in fact, not just assume it. Here we have assumed. I'm telling you that here. Because in potential energy, you can assume any point as reference. Right? But later on, I'll also explain why it will be 0 in this manner. Okay, going by some standard procedures. Okay. Anyway, so this is what we have for the potential energy of dipole placed in uniform external field. Uniform હોય તો બીજો નહીં. Okay. Generally એવું આવતું નથી, but still working it. Okay. Right? What is theta? Angle between dipole moment and angle between dipole moment and electric field. In your book, this derivation has been done with 2 methods. Okay, પહેલા એ લોકોએ વર્ક થી કર્યું છે, પછી એ લોકોએ બીજી રીતે. Okay, there's no need to do both actually. One is basically they have done it by the other way to explain why this is a natural or a good reference. Okay. Never mind. This is clear to you? Okay. Now, try this question, then we will go to the next section. Just write down the question. Use the usual symbols. Okay. Right. So this is the given position. Okay, that part is clear. A dipole is placed at rest in uniform electric field as shown. Find initial torque acting on it. You have to find torque on this dipole. Can you do it? Hurry up, come on. There are two questions. Okay, that's why I put space. But two simple ones. Torque. But what is P sin theta? Torque is P sin theta. So how much? Hurry up, come on. Initial torque will be equal to P E sin theta. So very easy to do. That is root 3 by 2 P E. Clear or not clear? Because theta is 60. Fine. Okay. So it will start spinning. Which way? Clockwise or anti-clockwise? Clockwise or anti-clockwise? Okay, control karo. It will spin. Yes, nothing करवाना. Logic use करवाना. Clockwise. Why so? Force acting on positive charge will be towards right side. Or left side. Right side. Who says right side? Force acting on positive charge, right side. Okay. Right. Fine. Yes, which one can you explain why? Louder.
Charge positive, the force field, electric field is in direction.
Well, if the charge is positive, the force on that charge and the electric field will be in the same direction. Clear or not?
Yes.
Everyone got that? Yes. Good job. Well done. Similarly, force on negative charge will be towards the opposite side. Either force lage to that. It will rotate forward. Is that clear?
Yes.
Okay. એટલે કઈ યાદ રાખવાનું તો એવું હોતું નથી. Just use these basic concepts. ચલો, thank you. So this will rotate clockwise. So what will happen after a while? Read the question and imagine what will happen according to the diagram. What's meaning of this word align? Align means it's the same direction. Yes or no?
Yes.
So theta will become 0. So it will start spinning like this. Theta will become 0. Okay, what do you have to do then? You have to find angular speed. Angular speed means what? Omega. Yes or no? Okay. Right? Omega. So this will rotate. And you have to find final angular speed. Initial angular speed is given or not given? Initial angular speed is given or not given? Given or not given?
Yes.
Given? How much?
0.
Like what is it? Take that rest. Is that clear? So initial angular speed is 0. Final angular speed we have to find. Now we're going to get it. From torque. Relation between angular speed and torque. What's that relation? Questions related to initial final speed and all that should always be tried by energy. Remember first, that's the first line of approach. Okay, try by energy. Yes or no?
Yes.
This is electric field. Electric forces are acting. Conservative or not conservative? Conservative. Okay, K1 plus U1 equal to K2 plus U. Clear or not? Everyone? Clear or not clear?
Yes.
બરાબર. એનો વિચાર આ ટોપિક પછી કેમ આવશે? So this is a combination of rotational motion and this topic. Formula તો યાદ છે ને? ભૂલી નાખો ને. So, what kind of motion this dipole is doing? Translation or rotation? Translation or rotation? Rotation. Correct? Sure. So, for rotational motion, what should we write for kinetic energy? Half I omega square. એટલું જાય ને half I omega square. Clear? Write it accordingly. Come on. As appropriate. Okay, at different places. Hurry up. So initial kinetic energy. Initial kinetic energy. 0. Very good. Plus initial potential energy. Minus PE. What is it? By 2. Why by 2? Cos 60. Clear or not?
Yes.
Initial angle is 60. Fine. Everyone get there?
Yes.
Okay. Our right side equal to K2. K2 half I omega square. This omega we have to find. Omega 2 square. Okay, we have to find final angular speed. પછી minus P E cos 0. Cos 0 is 1. Okay. હવે ગયું ને સોલ્વ કરી નાખો હવે ક્યાં અઘરું છે under root PT so to cancel I'm erasing what's on the left side. Okay. So when it will reach here, like this, its angular speed will not be 0. You understand it? What will happen then? Then it will overshoot. આગળ જતો રહેશે ને પછી પાછું આમ લાવો. Correct or not? શું થાય? Oscillation. Do you remember? Okay. So what's the answer to this question? Under root P by I. Omega 2 is under root P E by I. Okay? Yes. Clear everyone? Next topic. Equilibrium of dipole in uniform external electric field. It's related. Okay, now we will talk about equilibrium. So first of all, what meaning of equilibrium, everyone? Equilibrium करेगा. When total force is 0, it will be by. When total force is 0 on a system and total external torque is also 0. Both are necessary. Then it's called equilibrium. If it's only this, translational equilibrium. If it's only this, rotational equilibrium. They have to equilibrium. Is it okay? Yes. Fine. For a dipole in uniform external electric field, when is this true? Always true. Lydia, dipole placed in uniform external electric field. Total force is always 0. Okay. So this is always true. The tension. What about this? Now, how much torque acts on a dipole in uniform electric field? P sin theta. એક વસ્તુ તમને કહું, તમે ફોર્મ્યુલા તો યાદ રાખી નાખો છો. લખવા આપો તો ફોર્મ્યુલા લખી લો. પણ જે સેન્ટેન્સીસ લખાવું ને એ તમે લખતા એટલે એના કારણે થશે એવું એન્ડમાં that you will be limited to textbook words. કારણ કે ટેક્સ્ટબુકના ક્વેશ્ચનમાં મોસ્ટલી ફોર્મ્યુલા મૂકવાના આન્સર આવે એવું છે. Okay, so now everyone follow this advice. These sentences હું તમને લખાવું ગમે ત્યારે they are very very important. In fact, I say they are even more important than formulas. And these sentences the physics સમજાવે. We will be able to solve questions using them. Okay, and I sentences ઉપર ખાસ લખવાના પછી એક્ઝામ પહેલા શું કરવાનું હોય ખાલી નોટબુક ઉપર ઉપર વાંચતા જાવ બધું હેડિંગમાં લખેલું બધું આવડી જશે. Torque equal to P sin theta. Now, put it equal to 0. So P cannot be 0, E cannot be 0. Sin theta is 0. Theta is
0.
કોણ હતું? રાજ. રાજે કીધું 90. હે રાજ. મોકલી દે પાછળ 10 માં અલગ ક્લાસ. બરોબર ને? હવે theta is 0. બીજું કઈ? અરે બોલો બીજું કઈ? theta is 0 એના સિવાય કઈ આવે? આન્સર 180. હા. Okay, theta is 0 or theta is 180. There are two possibilities. Is that clear? એનાથી વધારે એંગલ નો આવી શકે કોઈ. Fine, everyone gets that? Theta is 0 or theta is 180. So there are two equilibrium positions. There are two equilibrium positions. Let's talk about the first one. Okay. So we go for theta equal to 0 first. So what would it look like? Here is dipole. That electric field line will also be in the same direction as the dipole moment. Clear or not? Waiting someone? How the electric field lines are in the same direction as dipole moment. Uniform field here, the field lines are. So angle between P vector and E vector is 0. Right? Angle between P vector and E vector is 0. Right. So we are going to decide whether this is a stable equilibrium or unstable equilibrium. We will decide whether this is a stable equilibrium or unstable. Okay, then decide. Do you remember what is meaning of stable and what is meaning of unstable equilibrium? Yes or no?
Yes.
Stable कौन है? If you displace it, it comes back to the same point. That's called stable equilibrium. If you displace it and it goes away, then that's called unstable equilibrium. Understood? Okay. So let's displace it a little bit. Suppose instead of being horizontal, let's say we tilt it at some angle, like we tilt the diameter, okay? Then what would happen? Say I'm tilt करना तो क्या दे turn करते हैं? Clockwise or anti-clockwise? Will it come back to this equilibrium position?
Yes.
Okay. If you turn it clockwise, then on its own it will turn back anti-clockwise. Correct or not?
Yes.
Fine. Everyone gets there?
Yes.
You know how to ready. So that would mean this is which equilibrium?
Stable.
Stable equilibrium. Okay, now. Okay, it is stable equilibrium. Now there is one more way to decide whether the equilibrium is stable or, and that is by potential energy. Okay. Here, do you realize that if you leave a ball like this, it has minimum potential energy of all points. Minimum क्या है potential energy? Is it okay? That point is it stable equilibrium or unstable equilibrium?
Stable.
Sure?
Yes.
Because if you displace it, it will come back. Similarly, look at this one. at this point it has highest potential energy. Yes or no?
Yes.
Yes or no?
Yes.
So this is
Unstable.
unstable. Link basically mind માં clear માં સમજાય રિપીટ કર્યું. હવે યાદ રાખજો બીજી વાર નહીં થાય. Is that clear?
Yes.
Okay. So write it. If u is minimum ઉપર લખજો જો આ કહું છું આ ઉપર લખવાનું હોય. Okay, this sentence is worth its weight in gold. બરાબર આનાથી તમને સમ્સ આવડશે. ફોર્મ્યુલા યાદ રાખવાથી સમ્સ આવડવાના નથી. તો ખાલી ફર્સ્ટ સ્ટેપ. What is it? If u is minimum, potential energy, sorry, if u is minimum, the equilibrium is stable. If u is maximum, potential energy is unstable. Potential energy equilibrium is unstable. I'll repeat that. If u is maximum, potential equilibrium is unstable. Okay. If u is minimum, then equilibrium is stable. Clear? તમે બરાબર લખ્યું હતું ને આવું ઝીણું ઝીણું લખીશું વંચાઈ ગયો ત્યાં વંચાઈ એવું તો લખ કે કઈ જરૂર નથી એવું વિચાર્યું ચલો વાંધો your methods for yourself. Okay, આ તો મારી method. If you try it, you'll see it works wonders. Okay, so let's see how it is minimum or maximum. First of all, u is equal to minus p cos theta. Correct? Okay. Ignore the minus sign for a while. So if we want stable equilibrium, potential energy should be minimum. So minus sign, the minimum so without minus sign it should be maximum. Yes or no? Because if you put a minus sign to maximum, it will become smallest. Clear or not clear?
Yes.
So without minus sign, this value should be maximum, largest. So cos theta should be largest. What is the biggest or the largest value of cos theta? Cos theta theta today. Cos theta's largest value is 1. Sure?
Yes.
And you get that if theta is sure?
Yes.
Theta is 0. That means potential cos theta will be maximum, u will be minimum. Is that clear? Okay, now for theta equal to 0 degree, cos theta is maximum. That is cos theta equal to 1. And potential energy is minimum. That is how much? Minus PE. Did you understand? Yes? No?
Yes.
So which point is stable equilibrium? Theta equal to 0. That is dipole moment and electric field are in the same direction. Do not make the mistake of taking it lightly. Chapter 5 માં આવશે સડસડાટ નીકળી જશે બરાબર કહું છું ફરીવાર ditto the same topic. ઓકે ત્યાં સુધી તમને યાદ ન રહ્યું તો તમારો વાંક હું તમને કહી દઉં છું ચોખ્ખું ત્યારે હું ભણાવવા બેસીસ નહીં સીધું કહી દઈશ ચેપ્ટર 2 પૂરું. Okay. Second, theta equal to 180. Okay, let's draw a diagram. So this time, dipole moment and electric field they will be in opposite directions. Like this. Okay. Well, let's see whether this is stable or unstable. Suppose we displace it a little bit. Let's see what happens. So that. Force on positive charge. Right side. Force on negative charge. Turns. Clockwise or anti-clockwise? Sure.
Yes.
Clockwise. But any equilibrium position so it was like this and you displaced it a little bit. Now, then will it go back?
No.
No? Sure?
Yes.
You displaced it and tilted it this way, and now it starts. So does it go back or does it just keep moving in that direction? Is that okay? It will not go back towards this position. Clear? આના જેવું છે વિચારી લો. અહીંયા છે ઉપર equilibrium. Say side માં મૂકો. Means you displaced it towards right side. Then does it come back?
No.
It will keep moving in that direction. Got it? So which kind of equilibrium? Unstable. In fact, everything is in search of a stable equilibrium. That's what philosophy third one. Right? Suppose you leave the ball from here and displace it a little bit. So that it will keep going down, down, down until it finds a point of stable equilibrium. Suppose I am going. One sec. Will it stop over there?
Yes.
No, it will not stop over there. So it will not stop over there. આગળ ગયા પછી આવશે. અરે stable equilibrium તો પાછળ રહી. What to do? Let's go back. Okay. પાછળ આવો. Make sense?
Yes.
So if there is no friction, then what will happen? It will keep oscillating. Got it? Right. Well, so just like this, for maximum potential energy, you are going to get theta equal to 180. So you get plus P. So even something because if you put theta is 180, cos will be minus 1. And then you put one more minus, so it will become maximum. Got it? Okay? So minimum and maximum potential energies. Right. Now what this means overall, what we have studied, either that way, this way, anyway. Take वस्तु विकल्प है. Whether from here or from here, stable, unstable, गमे दे. The dipole always tries to find the stable equilibrium. Yes or no? આમ થી હોય તો આમ પડી જશે. અને અહીંયાથી આમ મેળવે તો આમ પડી જશે. અહીંયા આમ તો આમ પડી જશે. Is that okay? It will always try to find the stable equilibrium. Clear?
Yes.
Sure? Okay. Look at electric dipole tends, means tries to align its dipole moment with external electric field. Electric dipole tries to align its dipole moment with external electric field. A very useful concept. Okay? समझ पड़ेगा ना समझ पड़ेगा. However you put it, it will always try to make P and E in the same direction. Clear? Okay? This is in fact the reason why pieces of paper stick to the core. Right? But every material is made up of atoms and molecules. Correct or not? They are dipoles. Yes or no?
Yes.
Yes or no? Sure. એની અંદર જે નાના નાના ડાયપોલ હોય ને એને ચાર્જ એટ્રેક્ટ કરવા માટે. The moment it attracts, it will rotate. That is, try to recollect. I think we have had this lecture. And if you have got a positive charge like this, let's say, and you put a dipole somewhere in this field, so do that. This will start spinning and come towards the charge. Yes or no? Make sense? Force on negative charge will be towards this side. Force on positive charge will be towards that side. It will rotate the side. But it will also be attracted towards the charge. Clear? So, what is the net effect? It will come and stick. Very समझ गए ना समझ पड़ी? It will come and stick. Okay? This is in fact very similar to how magnets behave. This is very similar to how magnets behave. right? અહીંયા strong magnet હોય તો એનું magnetic field હોય. અહીંયા તમે નાનો એક magnet મૂકો તો એ જ rotate થઈને ચોંટી જશે. Okay, depending on which pole it is, right? અહીંયા south pole હશે તો આમ ફરીને ચોંટશે. અહીંયા north pole હશે તો ઊંધું ફરીને. But it will always come and stick, right? Got it? So basically dipoles always try to rotate and they get aligned. The moment they get aligned, they will start getting attracted, right? The moment they get aligned, they will start getting attracted. Negative charge hoy to એવું થાય. I hope you realize that. In that case, if it's like this, so arm rotate થશે. Positive આ બાજુ જશે. Okay, if you keep it this way, then it will rotate the other direction. Okay, and once it rotates, there is no stopping it, because if it becomes like this, then obviously this charge is closer, yes or no? So it will have more force compared to that repulsion. So once it rotates, game is over. It will always come and stay. This leads us to something very strange, which you might not be ready to believe at start, but it's okay. You will understand eventually. It is charged bodies. Lockjaw attract neutral bodies. So મજાક છે, ન્યુટ્રલ છે, ચાર્જ નથી તો એટ્રેક્ટ કરી લેવાનું, કરી લેવાનું. Charged bodies attract neutral bodies. Repel no કરી શકે, attract જ કરી શકે. Not due to gravity. No, please, I'm not saying that. Sir, gravitational force. No, I'm not talking about gravitational force. There acts Coulombian force or electrostatic force between a charged body and a neutral body. Let me give you a very simple example. Suppose here you have, let's say, a charged metal rod. Suppose positive. And for sake of simplicity, from an insulating thread, suppose there is a neutral metal sphere. Easy, metal में एकदम easy to समझे. The moment you bring this little bit close, आतो neutral से इन पर charge है कि नहीं? नहीं है. This charge will start attracting electrons from the metal and they will come on this surface. Yes or no?
Yes.
And positive charges will settle on the far surface. હવે આ અહીંયા હોય. So positive negative are closer to each other compared to positive positive. Yes or no?
Yes.
So what is more? Attraction is more, repulsion is more. So answer that. Does it have charge? No, it has zero charge. Still it gets attracted. Does that mean a proton can attract a neutron? Does it mean a proton can attract a neutron? Like this. Suppose एक proton आम रहेगा, दूसरा proton आम दूर रहेगा, तो attract થઈ જાય? Okay, no, because inside proton charges cannot move. You understand what I am saying? Inside proton charges cannot move. Clear? Practically, protons and neutrons don't have size. Do you realize for this to happen, it has to have a size? Sure? Absolutely. I am like a point charge or so that. So खाली repel है क्या attract? Okay, depending on whether this is positive or negative. एना बदले खाली neutron जो तो कहीं ना. Okay, obviously it's not possible to do it. This is just a thought experiment. अपन ओलू तो real है तो समझ पड़ेगी नहीं. Then if you take a sphere and here's a positive charge तो यहाँ पर. Okay, sure. Well, so don't forget that sentence. Anybody digital content. Repulsion is true test of charge. Another meaning. If you want to know whether a body is charged or not, if you want to know whether a body is charged or not, then you have to look for just one thing. What's that? Repulsion. Attract तो गमे ने कर सकते. Gravitation also attracts, and this sentence also means that neutral body will be attracted by another charge. So it's like if I tell you that, well, here we have some object A, object, particle, and some object B, and they are attracting each other. then is it necessary that both are charged? No. It is possible that A has negative charge and B has no charge. Then also they will attract. It is also possible that A is positive and B has no charge. Then also they will attract. It is possible that A has no charge and B has negative charge and vice versa. Okay. Then there is one more thing. It is possible that both have no charge. Then also they attract. Gravity. Gravitation. Don't forget gravity. Clear or not? It's there. It's less, but it is there. Clear? But repel क्या रहता है? Only when they have like charges, only in that case they can get repelled. Then if you want to ensure or you want to verify whether the body has a charge or not, so attraction छोड़ो, repulsion करावी दो, repulsion થાય तो charge, otherwise can't say. Okay, if there is no repulsion possible in any way, that means it will not have a charge. Clear?